Hey, what's going on, everyone? It's Justin Dickmeyer from EngineerInTrainingExam.com. In today's quick tutorial, we're going to review functions. We'll start off by defining a function and function notation, discuss how to evaluate a function, define domain and range, and then finish off with function composition. So what is a function? An equation will be a function if for any x in the domain of that equation, the equation will yield exactly one value of y. So the definition criteria for an equation to be a function is for all x in that domain, there's only one value of y. So if we can satisfy this with an equation, then that equation is a function. So let's illustrate that. Look at y is equal to x squared plus 1. So is this a function? Quickly, I would say yes, this is a function because given any x, there's only one way to square it and then add 1 to the result. So no matter what value of x we plug in here, there's only going to be one value of y. One value of y satisfies our criteria, so this is a function. Let's look at y squared is equal to x plus 1. For this second equation, the only difference is that we move the exponent off the x and onto the y. This small change is all that is required in this case to change the equation from a function to something that isn't a function. We can see that this isn't a function fairly simply by plugging in any x. Let's just plug in 3 and solve for it. So y squared is equal to 3 plus 1, which is equal to 4. Let's solve for y, and we see that it's going to be plus or minus 2. That's two values of y. It does not satisfy our definition criteria for a function, so this equation is not a function. So let's talk function notation. Function notation is nothing more than an elaborate way of writing y. So let's look at the equation. Y is equal to 2x squared minus 5x plus 3. So if we want to write this equation using function notation, we can substitute the y as f of x. We can substitute it as g sub x. We can substitute it as h of x, etc. We just plug in what's on the right side, and that's function notation. So recall that this is not some letter, say f, multiplied by x. It's just like I said, an elaborate way of writing y. Using function notation allows us to represent the value of the function at a given x within a domain in a clean and compact way. So how do you evaluate a function? Let's take that same function. F of x is equal to 2x squared minus 5x plus 3. And so to evaluate this, wherever we see an x on this left side, we plug in whatever x we decide to plug into the function on the left side. So let's take f of negative 3 and just plug it in on the right side. It's that simple. And then using math, we'll just go ahead and quickly solve that. Just trust me that it equals 36. So let's talk about domain and range. This is one of the more important concepts of a function. The domain of a function is the set of all values of x, all values that can be plugged into a function and have the function exist and have a real number for a value. So the domain, we need to avoid anything of division by 0. We need to avoid square roots of negative numbers, logarithms of 0, etc. Anything that makes a function non-existent. The range of a function is simply the set of all possible values that a function can take. So let's quickly find the domain of a function. Let's say we have f of x is equal to x minus 4 divided by x squared minus 2x minus 15. So in this case, we want to avoid division by 0. So let's isolate x squared minus 2x minus 15. And since we don't want it to be a division by 0, we have to determine what values of x will make that equal to 0. So let's set this function equal to 0, factor it. X minus 5 x plus 3. And we can solve that and see that x is equal to -3 and x is equal to 5. So the domain for this function, the domain will be all values of x except x equal -3 and x equal 5. So let's talk about function composition. Let's say we have two functions, f of x and we have g sub x. The function composition of f of x and g sub x can be written as f g sub x, which is equal to f with g sub x plugged into that function. So in other words, compositions are evaluated by plugging in the second function, which in this case is g sub x, into the first function, which is f of x. So let's look at an example here. Let's take that same composition of f g sub x and let's use the equations. Let's say we have f of x is equal to 3x squared minus x plus 10, and let's say we have g sub x is equal to 1 minus 20x. So all we need to do is plug g sub x into f of x. So this will equal 3 120x squared minus 120x plus 10. So we can solve that out. Just trust me that it's going to come out to 1200x squared minus 100x plus 12. So the order in which the functions are listed is important. Interchanging the order will usually result in a different answer. And we can illustrate that by using the same functions here. Let's use f of x is equal to 3x squared minus x plus 10. Let's use g sub x, the same one, as 1 minus 20x. This time let's plug f of x into g sub x and see what we get. That will come out to be g sub 3x squared minus x plus 10, which is equal to 1 minus 20, 3x squared minus x plus 10, which is equal to minus 60x squared plus 20x minus 199. So to compare that to the previous example, we see that by interchanging the same functions that we got two different answers. So that's all I got for you guys today. I hope you guys enjoyed that quick review. I know it was a fundamental and that you probably are right up on this stuff, but I just wanted to touch briefly on it. So check out my website at engineeringtrainingexam.com for more resources in leadership.